All right. So what we're going to cover today, we're going to go through some introductions, then go through an overview of unit testing and why we think it's so important. From there, we're going to go into a review of Mocha and Chai, which are two of the most popular unit testing frameworks that are out there for JavaScript. We're going to review our virtual Alexa project, which is a project created by us, Bespoken, that really helps a lot with unit testing for Alexa skills. We're going to go over implementing code coverage and show you how you get that set up, as well as configuring continuous integration. And then we're going to leave some time at the end for questions. Though again, as I mentioned, do feel free to just ask them as we go through here. So as briefly on introductions, I'm John Kelvie. I'm the founder of Bespoken. I'm also joined by Yvonne Perez, who you'll see there in the chat window. And Bo Schrader is, I don't think, with us today. And what do we do as Bespoken? We provide monitoring and testing tools for voice apps. We're very proud to be a recognized vendor of Amazon and Google. We have over 800 apps being monitored and 1,500 developers using our platform. And we have a long history with speech recognition and AI. We've been scaling it and testing it really even well before Bespoken and even before the Alexa and the Echo. And that experience that we have testing and working with speech recognition at scale, it really informs what we do product-wise at Bespoken. So what do we want you to come away with today? We want you to know about unit testing tools that are out there. We want you to have a great template for building out a unit testing enabled Alexa project. So the project I'm going to be walking you through, you can really use that as a basis for adding tests to your own project. We want you to have a step-by-step roadmap for implementing unit tests. And really, step-by-step, we're going to take you through each part of getting this set up. And we're not really going to leave anything out. We are going to go through it relatively quickly. But you should come away with a very tactical understanding of what's involved in setting up these unit tests. And then lastly, we're going to go through some of the more advanced use cases. We're not going to go into complete depth on those, but we want to show you some of the more advanced things that you can do to give you an idea about how powerful unit testing is and where you can go from here. And that's really the last part that we want you to come away with, which is to arm you with these basic pieces and then show you the roadmap for going forward. So those are really the key elements. And with that, here's an overview of unit testing that we want to go through with you. So this may be familiar if you came to our previous webinar, but just, what are the goals of unit testing, and how are you accomplishing it? Unit testing is really about testing your code in isolation. It allows you to quickly identify bugs, and it allows you to ensure that your code is written to a high level of quality. It's very focused on testing things in isolation to see that they work without dependencies. And that's really important because you do want to make sure that your code is functional by itself without worrying about the database or the AI, S3 configuration issues, whatever you might have. You really want to initially have that focus on your code quality. And with that, besides being able to get a good gauge about the quality of your code by hooking it up to things like code coverage tools that we'll show you, which are really helpful or provide really helpful metrics on your code quality, It can be really helpful as you're developing in quickly identifying bugs, and being able to jump to where there might be problem areas. And so to that point, I think most people know that there's really a long-term ROI to unit testing. That long-term ROI manifests itself in that if you are using good unit testing practices, and you're uncovering bugs early in the process, you're far less likely to incur the expense of having a bug once it gets into production. And this little chart here sort of shows you what that expense is like depending on where you uncover a bug. So the difference between the cost of a bug at design and the cost in maintenance, when it's in production, is 2 orders of magnitude. And, I think we know that to be true just from our experience where we see the type of personnel that have to be involved. You have your customer support, you have DevOps or system administrators that are involved in doing new deployments. You have coders that are making an emergency fix. You have sort of wild goose chases that will go on with production environments. All of those things make production issues far more expensive. And it makes it much cheaper if you can find those early in the whole process. And I think, not many people would challenge that premise or really disagree with it. We all believe there's a long-term ROI to automated testing. I think what's less well accepted, but I'd really like people to also keep in mind, is that there's a major short-term ROI as well. And I find that the analogy to cooking perhaps is helpful in making that. And that is that if you keep your workspace very neat and clean, you're going to not just have a higher quality outcome, you're also going to get things done faster. And so I was sort of entertained by the movie Ratatouille. They have this funny scene where the one chef is telling the other about how important it is that they keep their workspace very neat, and that if they don't do that, it's going to cause all the orders to back up. They're going to cook slower and they're going to cook worse. Well, I think the same thing holds for your code. So if you have a neat, well-organized, high-quality workspace, you're not just going to have a better outcome, you're going to get your work done faster. And as we go through some of these examples, I'll try to point out how that is true. And so it's really important to keep that in mind. You have this long-term ROI with unit testing, but you also have a short-term ROI. And so if you're sort of putting off getting into doing your unit testing because you think, well, it's great, it sounds great, everything that I've read or everything that Kelvie here is saying, but we have this deadline coming up, and the sort of message that we have is like, well, you're going to be able to reach that deadline sooner if you're using unit testing. So enough preaching on that. How does this come together? So we're talking today about just unit testing. If you joined us previously, though, you know that there's more that we offer than that. And really one of the other essential pieces that we have out there is our end-to-end testing tool, which we call our virtual device. So the two pieces that we see really working together in automation for testing, we have Virtual Alexa, which is our emulator. We're going to go through that today. And then we have our virtual device, which, unlike the emulator is just generating JSON as if it's coming from Alexa, but it's not actually using Alexa. The virtual device is actually interacting with Alexa. So it's taking some text, generating audio, using text-to-speech based on that, sending it to the Alexa voice service. The Alexa voice service is in turn sending it onto your skill. Your skill replies with audio, which in turn is run through a text-to-speech engine, which is then creates more text, which you can use for tests in your code. So when we look at tests that use either one of these pieces, you'll see that it's basically looking at some input, or sending an input and then comparing output to see that the right message is received. But the pieces that it goes through are really very different. And we're not going to spend as much time on this virtual device or end-to-end testing. We may do a deep dive on that in a future session. But we do want you to be aware that that is out there, and that we really see these two pieces working hand in hand. So with that, we're going to take a look at our project. And the first thing that we're going to do is we're going to get set up with Mocha and Chai. And Mocha and Chai are two really popular frameworks for JavaScript testing. Mocha is a test runner, and so its job is to actually help you run or to configure and execute your tests and get the results from them. And then Chai is an assertion framework, and it's going to help you with doing your comparisons of your expected outputs against your actuals. And so, if you've used Mocha, you're probably aware that there's actually an assertion framework that's built in there. We specifically bring in Chai for that because, one, it's a much richer assertion framework. Two, it actually supports a couple different testing philosophies, let's say. And so there's two major ones out there, and they are test-driven development and behavior-driven development. Test-driven development is really about, it's an idea that says, okay, before you actually write any code, write your tests first. And as you're writing your tests, or after you've constructed all your tests, then you're going to fill in your code, and you're going to see all your tests go from not passing to passing. And it's a neat way to do development. It's very popular among a lot of developers. And behavior-driven development actually extends on that further by coming up with a language for writing tests in a way that's very use case centric. And so you'll see, we're going to show you a particular syntax that Chai has, and it's meant to be very, very friendly, very readable. And that's part of behavior-driven development. And with Chai, you actually have built into it two different syntaxes for doing your assertions. And you can take your pick between them. I think they're both very readable. But it's, besides being very flexible, it also does support these two philosophies. And that's a brief overview of them. I would sort of encourage you to go and you can read more about them. But they are very interesting, and they can be very helpful to you as a developer. And so to get them set up, so I've got my project window here. And actually, first let me show you the project that we're working with. So we're starting off with this, and it's a really simple class that we have here. This is about as simple a skill as you can get. It's just hello world. It has a single custom intent, hello world intent. Really not complicated at all, but it's a good basis for us to set up all of our unit tests code coverage, continuous integration, everything like that. So a really easy one to sort of follow along with. So I'm going to go ahead to the command line here, and I just say npm install Mocha save dev. And then I'm going to install Chai. Okay, so great. So now I've got those two pieces installed. If I look in my package.json here, I can see that they're set up. They're under dev dependencies. I don't need them as a regular dependency because they're not going to get actually installed at runtime. They're just here for when we're doing our development. And then for an initial test, this guy should have been reverted. We can take this right here. And this initial test, this is not really testing anything substantial. Instead, this is just demonstrating that our environment is set up correctly. So we have 2 unit tests. And this first one, it should agree that true is true. That's kind of a self-evident statement. But you see here then the assertion that we make, expect true to be true. This is an example of the behavior-driven style of writing unit tests. But we've created this to confirm that Mocha and Chai are set up correctly. And then we have this second test here. This is really meant to demonstrate that it's configured correctly for an asynchronous test. And the reason why we want to highlight that is that, as Node.js developers, and we're going through a Node.js project here, we're accustomed to having a lot of things done asynchronously. And so we want to make sure that we show you an example of that, and that you see what those mechanics are. And so for that, it's really straightforward. You take a function, or you take a parameter done, and that needs to be called before the test finishes. So it's expecting that to be explicitly called before the test will exit. So if I go back to my command line here, I can run npm test. And both those statements are going to execute. They're both going to be shown as green. You're going to see that this takes 506 milliseconds. And that's because I have this set timeout of 500, so it's going to delay it by 500. And so just running this test, we added this line here to our project. And that's just telling Mocha, run anything under the test folder that starts with star test.js. So if I run this again now, just after commenting this out, I'm going to get this failure if I don't explicitly call done. So really straightforward there. And I don't know if there was I heard a little dot there. I don't know if there was a question. But so now I want to go ahead and I want to actually add in some tests that will test the real behavior of my skill. So my next step is I'm going to do install virtual Alexa. And you see that I'm just going back and forth actually to this project here. I have each of the steps that we're going through set up as a branch. So it's kind of like a little cheat sheet here. And so to get the virtual Alexa piece set up, I just installed it. I do my require. And let's take this test first. So we just want to do a launch on it. We'll take out this filter for the moment. And so the launch is going to emulate somebody actually just saying open skill, you know, open hello world, or whatever the name I happen to select is for this skill. And it's using promises. So it says launch then, and then we write a couple tests against the output. And so we're just taking the SSML off the JSON that comes back, and we make sure that it includes the phrase hello world. So a really straightforward test. And let's go ahead and run that. Oops. And I also, so that error I just got is because I neglected to define what is Alexa. So that's an important step. So let's take this piece here, and we'll walk through how that's set up. And so this before each means that it's going to be run before each of the tests, fairly intuitive. And within it, we're going to configure our virtual Alexa component. And there's really two key pieces that we need to give to virtual Alexa. I see. And the question is, what is NYC? I'm going to come back to what NYC is in just a moment, so you'll see that. But good question. But we are going to cover that in just a few minutes. So with this handler, we need to tell virtual Alexa where the lambda is that we're using. And so in this case, it's under source, and then it's index.js, and then the dot here. This first part of the name is the file, and then the second part is the function in the file. So it's the handler function within index.js. So we say index.handler there. And then we also point it at where our interaction model file is. And that's under models en-us.json. And so this is using the new ask-CLI syntax, or interaction model setup. So with that, we have our virtual Alexa configured, and we can go ahead and run it. And great, we get a result that this is passing as well. And inside our skill, we're actually printing out the JSON that's received. So that's right here in this console log statement. And so this is the actual request JSON that comes through, which should look fairly familiar. And so with that, we have a basic unit test running against our launch. And let's go ahead and test one of our utterances. So our utterances are pretty simple as well. We go in here and let's say utter hello world. And so just any of these samples here will work. So we add that in, and then we can run test again. And great, now we have 4 tests passing. So lots of nice stuff happening there. And one thing I do want to highlight before we move on from this is how this filter works. So if you want to get into some more advanced use cases, if you want to be able to directly manipulate the JSON that's sent to your skill, which can be quite handy, you can set this filter. And the filter is going to receive the request before it's sent to the skill. And so you can go in and look at that request JSON and do anything that you want to it. And so I'm actually also going to use this as a chance to show you how to set a breakpoint in here. This is a really helpful feature, is that you can step through your skills. So I'm right-clicking on this and I say debug should launch the skill and get a response. And just like that, it's going to run this test and it's going to jump to this breakpoint. And so I can see my request. And this is, again, this is before it's actually been sent to the skill. And I can manipulate it however I want. And so in this case, I'm adding a couple supported interfaces. And then I can add another breakpoint so that then I can pause it when I get that response. So pretty neat. This is a very powerful tool and extremely useful as you're doing your unit testing. I'm using WebStorm here, which is a popular integrated development environment, but there's obviously many others out there, and pretty much any development environment that you're going to use today, it's going to have the ability to do this sort of debugging. And we strongly encourage you to take advantage of those features, whether you're using Atom or VS Code or WebStorm, or even if you're not working in JavaScript, you can write your unit tests and step through them, and it's a really helpful thing. And so with that, we can actually get our code coverage set up. And this is going to answer the question around what is NYC. So to set up code coverage, there's 2 pieces we're going to install. One is NYC, which is also known, NYC is it's the CLI of the Istanbul package, which is probably the most popular, in fact, it may be the only um, code coverage package for JavaScript. At least it's the only one that I really regularly use. And so we use NYC to create our code coverage locally. And then we also use CodeCov, which is a nice hosted tool. There's actually a number of these. CodeCov is our favorite, but Coveralls is another popular one. And so we're going to set that up as well. And then to actually configure it to use it is really easy. So all we do need to do is we add in here this NYC call in front of our call to Mocha. And what that's going to do is that's going to generate code coverage artifacts as we're running our tests. And there's one other little piece we need to add here. And so we're going to run our tests, and we wrap our call to Mocha with NYC, and that's going to generate code coverage data. And then we also, after the tests are run, we tell NYC to generate reports. It's going to generate reports in JSON and HTML. The JSON is for CodeCov. And the HTML you'll see in a moment. And that's really for us in terms of using our test locally. So we'll see how that looks. So we added those pieces, and then we can just run npm test again. And the CodeCov does fail when we're running it locally. But when we actually run this in our CI environment that we'll show you in just a moment, this actually just automatically works. So the error that it's reporting here where it doesn't have a repository token, that's taken care of automatically when we're actually running it directly with GitHub and our CI, which you'll see in a moment. So if we look over here, here's our coverage folder, and we can take a look at this index.html. So this is the report that's generated by running NYC there. And we've just got one file here that's being tested. And it's got a 57% coverage. And when we look at it, this is a really helpful thing because we can see here where tests are being run. And so we have over here the 1x, 2x, 2x. And so all these functions are being tested, whereas these are not. So let's go ahead and add an additional test to improve our coverage and to get this help intent working. So to set that up, we can actually just copy this guy here. And we can say utter help. That's very easy. And then we want to make sure that it has a message that comes back. This is the hello world sample skill. And we change the name there so that it aligns with our test. And we can go ahead and run npm test again. And now we see that additional test is passing. And then we can also go over here. And now these lines are green. We have these little notes here with the 1x. And our code coverage has gone up to 80%. And so we can really keep that going and test all of these intents. I'm not going to go through all of them right now, but you can see how it's quite straightforward to add test coverage for these other pieces as well. So that's a really neat thing. With that set up, we can now actually tie this into our continuous integration. So the CI piece, with everything else that we've done, it's actually really easy to then get your continuous integration configured. And so there's really two things that we need to do there. One, we're going to set up Travis and have a travis.yaml file. And so the contents of that it's really simple to get this configured. And so I actually already have it in here, but if I was creating it from scratch, I'd just go in here. And all I'm doing is I'm telling Travis, our CI tool, that we're using Node.js and what version of it we're using. And then if I go into Travis here, I did already toggle this project, but if I hadn't set it up already, I would go into this list of repos that I have. And so Travis has, I've signed in with GitHub, and so it sees all my public GitHub repos, and I just go ahead and toggle my project. So I check that box there. So that, along with that YAML file, that's enough for Travis to then do its piece. And so if I go and look over here, I've got my project set up and it's being run. We're getting output that's just like we had on the command line. So 5 tests are passing. So that's great, right? And there's a lot more to CI tools in this. I mean, we're not going to go through all of it. But just having this external environment where it's running my tests, and it does it automatically whenever I make changes, that's extremely helpful. And then in addition, I mentioned that the code cov piece, this part just works as long as I have it set up for a public project. So I can then go and actually look at code cov. Come on. And hopefully that's not an internet problem. Okay, no. Maybe I'm just having a problem hitting code cov. All right, I think code cov is maybe having some maintenance. Well, if we were looking at code cov, we would see output that's very similar to this, what we have locally. But the nice thing that you actually get with code cov and with other tools, other hosted code coverage tools, is they'll have some nice graphs, and then they're going to show you the performance of your code coverage over time. So once you have these pieces set up, as you're adding code, as you're adding tests, to be able to see it improving over time is a really helpful and useful thing. And so with that, we now have really a complete automated testing regimen set up in our project. So that's really terrific. And we went through all the steps there so you can see that, I hope you can see that it's really very straightforward to do this. And so we want to take a moment and actually take a look at some of the more advanced things that we can do. So there's a couple projects here that I want to show you. So one of them is guess the price. And this is a skill that we published that really has very good tests set up for it. It's a game that's sort of like The Price is Right that we have. When you come in, it says, welcome to Guess the Price. It asks you what your name is, or it asks you how many people are playing, asks each player what their name is, and then it starts the game. And in the game, it asks you to guess the price of an item. So you're going to actually guess dollar amounts for different items. And so to the point I was making earlier about being able to debug complex skills, here's a multi-step skill with multiple different states. And if we have a bug that's, say, in the 5th step, only for particular states, by having this unit test set up, it makes it much easier. And then I could just set a breakpoint and then just jump to this step. And so that really makes our debugging much simpler. And so in that way, that's really, I think, a prime example of how you can really save yourself time by having unit tests. If you're going through and manually doing each of these steps by talking to a device, it's really much, much slower to do your testing, to do your debugging, than if you have this sort of unit test set up. And I think if you look at this, you can see that it's not very complicated to do all this. I mean, a lot of your work is actually just getting your unit test pieces in place. Once you have it, to write out the different steps, I mean, it takes a couple of minutes. And then so once you have that, though, you really can do your development and debugging much more quickly. And so we have a lot of tests set up, going through a number of different scenarios with this project. It's really a nice one in terms of the completeness of the coverage. And I would also just mention that this takes advantage of the async await. And so we don't have to use that promise structure, and it just makes things a little more readable. So rather than saying alexa.launch then with the promise, instead we're saying await on it. Now we're still compiling this to Node 6. If you look at your different node compatibility, Node 6 does not have full support for async await, and so we actually use Babel to do cross compilation. So Babel's kind of a neat tool that'll allow you to bring in features like async await to older versions of Node. And just before I go further, I'm just going to take a quick peek at our questions here. Okay. So that guess the price is a great example. Another one that we want to show you is the super simple audio player. So another neat feature of Virtual Alexa. It does support writing tests for the audio player. And so this is another project. You're gonna see that it's configured in a way that's very similar to the other ones that we've shown you. But in this case, we're actually working with the audio player. And so we have an utterance like play, and when we say play, we're expecting a directive to come back that's going to tell the audio player to play a particular stream URL. And once we receive that directive, we're going to tell it next, which is going to signal another URL to be played. And so that emulates the user saying next. But then we can also send requests that equate to system level events like playback nearly finished. So if you've done much with the audio player, you know that it's typical that you're going to wait for a playback nearly finished event. And when you receive that, you're going to queue up the next track to play. So we go ahead and send that playback nearly finished. And then based on that, we enqueue, or our skill is sending back an enqueue directive for the next episode. Simultaneous though, and this is one thing that's really neat, is so we've enqueued the next track, but it has not started playing yet. We're still playing the previous track. And it's not until we say playback finished on the previous track that queued up track then begins. So after we say playback finished, then this next track will begin. And that's sort of some magic that we have inside the virtual Alexa, which is actually emulating the state of the audio player as if it was a device. And the fact that it does that behavior is really helpful for writing unit tests. So that's a really nifty thing. If you are using the audio player, we really encourage you to check it out. And then just a few other topics that are worth mentioning. If you're working with Dynamo, there's a nice component we have that mocks out Dynamo from Alexa or within the Alexa Node.js SDK. Very easy to set that up. That's something to take a look at. If you're using Dynamo, it's something that comes up very frequently. If you're just generally dealing with dependencies, we highly recommend the module knock. I'll show this real quick. Knock is really great for mocking out, pretty much any HTTP-based dependency. It's very easy to work with, and it's really going to allow you to do your testing without relying on external web services. And we showed you that filter piece there. And that covers most of what we wanted to go through here. We've got about 7 minutes left. Any questions? What else can we go through? All right, I don't think we. Oh yeah, so please take a look at the poll. Please do fill that out. Thank you for that reminder, Yvonne. Um, and I think with that, we can actually probably wrap up. Really appreciate folks joining. I hope you found this very useful. We appreciate any feedback on this, especially around other subjects you'd like to see us go through. We think unit testing is really an essential part, and we see probably doing some future ones on the end-to-end testing piece that we mentioned, going into that in more depth. But we'd love to get your feedback on what you think we should be talking about. All right, well, great. Well, thank you. Have a good morning or a good day, and we hope to see you on another webinar soon.